Max Compression System. Water will be the coal of the future. Tomorrow's energy is water that has been broken down by electricity. The elements of water broken down in this way, hydrogen and oxygen, will secure the energy supply of the Earth for the foreseeable future. Let's continue writing Jules Verne's story together and make his vision come true with our technology. Maximator offers gas filling stations for using hydrogen as a source of energy for sustainable mobility. To understand the structure of these stations, let's take a look at a simple block diagram. No, in fact, let's make this even simpler. Filling up vehicles with hydrogen requires pressure, which is why the gas filling station features a pressure supply unit. This unit is the heart of the system and is called Max Compression System. The Max Compression System consists of multiple modules, which we will now take a closer look at individually. To do so, we must open the doors of the container. Inside the container, we can find all the components required for generating pressure. For example, there are various process chambers, which are divided into an ATEX area and a non-ATEX area. In the ATEX area, the hydrogen is compressed to its final pressure by 2 piston compressors and in 2 steps. For that purpose, the hydrogen is pre-compressed in the so-called Max Compression Stage 1. To reduce the temperatures generating during the compression of the hydrogen must subsequently be cooled. Therefore, a cooler, the so-called Max Cool, is provided in the Max Compression System. The flue pipe outside the container serves as a safety device, which all pressure relief devices lead to. After the cooling process in the Max Cool, the pre-compressed hydrogen is led to the compressor called Max Compression Stage 2. Here it is compressed to its required final pressure and is then also cooled via the Max Cool before leaving the Max Compression System. Besides Max Compression Stages 1 and 2, as well as Max Cool, the Max Compression System contains a few other modules. For example, the compressors need to be driven by a hydro unit, the so-called Max Power. Max Power is equipped with an electronic motor which drives an axial piston pump that hydraulically actuates the 2 Max Compression stages. In order to pneumatically actuate the built-in valves, the Max Compression System also requires a compressor, the so-called Max Auxiliary. Both Max Power and Max Auxiliary are located at the rear side of the Max Compression System in the non-ATEX area and thus complete the heart of the system. Now let's describe the process inside the Max Compression System in quite simple terms. The hydrogen enters Max Compression System. It reaches the Max Compression Stage 1, where it is pre-compressed. After pre-compression, the heated hydrogen is led to the Max Cool, where it is cooled down and then fed to the Max Compression Stage 2. Here the hydrogen is compressed to its final pressure and led through the Max Cool once again before leaving the Max Compression System. In order for the hydrogen to be compressed, the 2 Max Compression stages must be hydraulically actuated by Max Power. Since this is a closed hydraulic system, the oil is returned via a return system. For the automatic compression of the hydrogen to work, both Max Compression stages must be supplied with compressed air. This is done by the Max Auxiliary. The interaction between the modules in the Max Compression System allows the hydrogen to be compressed to the required pressure and to be provided for further use. The Max Compression System is indispensable for the gas filling station. However, there are a few other modules that are also required for the structure and which we will take a look at in the next step.